Hello dear friends, another question. A resistant wire is connected to a cell. The length L of a wire is changed by pulling the ends of a wire. So we pull the wire so that the length is changing. Okay, the volume of the wire remains the same, but the volume does not changes. Okay, what is the correct relationship between the resistance R and the length L? So I will explain what is going in this question. So for example, if we have a certain wire that has length L and the length is capital L and the area is A. The area of cross section is A. For example, if we pull this wire by applying the stress, when we pull this wire, so this wire, this length of the wire increases. So as long as the length of the wire increases, you know that if length increases, so that the area got reduced, so area decreases, area of the wire decreases. So we need to find the correct relationship between R and L. So we use the equation first. R is equal to rho L over A. This is the required equation. Now we see that if we use this equation directly, so it will give us the wrong answer, because we know that if length increases and area going to reduce. Okay, so we can't predict the correct relationship between only the L. Okay, because it is also given that the volume remains the same. Okay, volume does not changes, volume remains constant. Okay, so in this problem can only be solved by reducing this area L into volume and the length elements. So in order to do that, so we can write, as we know that volume is defined as volume is equal to area multiplied by the length L, because area into L is the volume, V is equal to AL. So you can find A is equal to volume V over L. So this is equation number 2. If we put this A value in this above equation number 1, so we are left with the equation 1 becomes, as we know that R is equal to rho L and area is volume of V over L. So this L can be multiplied to the denominator. So R is equal to rho L square over volume V. Here you can see that, as we know that rho is constant, volume V is constant, so we can see that R is proportional to L square. So mean if rho is, because we know that rho is the resistivity, and resistivity is the material property, it depends on the only the material. Okay, so as the wire is the same, so for the same wire, so rho value of the resistivity is constant, and the volume V is also know that it is given that volume V is constant. So if these two things are constant, if these two things are constant, if these two rho and the volume V is a constant, so R only depends on the length L square. So R is correct answer is R is E proportional to L square. So the correct answer is R is proportional to L square. This is our required answer. C option is the correct one. Okay, thank you.